Okay, your bank is offering 5% interest rate compounded continuously. So there's actually two different questions here, right? The first question, if you deposited 5,200, how much money do you have after 2 years? And then a separate question is, when would your account balance reach 6,000? Okay, so let's just focus on the first question, but I'll go ahead and divide the space in like half. Okay, maybe we should have left more room. Sorry. The first question takes much less space than the second question. So let's just do the first question. Okay, so compounded continuously. If you remember back to 4.1, we have three different interest formulas. The one that's compounded continuously is A equals PE to the power of RT. Okay, so the principal is the starting amount. So you're starting with 5,200. The interest rate is R. So remember, 5% you need to convert to decimal form. Even though there's a decimal point, it's currently in percent form. So you just move the decimal point twice to the left. Okay, so R is going to be 0.05. And then for this first question, the time is 2 years. Okay, so let's go ahead and substitute those values in. We don't know capital A, which remember is the balance or the ending amount. But we've got P is 5,200. E is not a variable, it's Euler's number. It's always worth the same. And R is 0.05 times T is 2. Okay, so the variable is already by itself, right? So all we need to do is simplify the right side. Okay, so you'll need your calculator for this. Okay, so 5,200 times e to the power of 0.05 times 2. Okay, again, your E button is likely related to your LN button. That's not a coincidence, right? We know E and LN are related. Okay, so 5,200 times E to the power of 0.05 times 2. Okay, so if the problem tells you where to round, of course, do that. But if they don't tell you, you would go to the nearest cent. So this 8 is followed by a number that's 5 or more. So you round the 8 up to 9. Okay, so $5,746.89. Okay, so that's the first question of this situation. The second question, when would your account balance reach 6,000? Okay, so this time I'm asking you for the balance. I'm telling you that I need A to equal 6,000. Okay, and now the question is when, meaning what time? So T is the unknown for this problem. Okay, so you still start with the full formula, A equals PE to the power of RT. But again, this time we know the goal. We need to get to a balance of 6,000. The principal is still the same. You're still starting with 5,200. The interest rate is still 0.05. But we don't know T. Again, T is not 2 years anymore. That was the first part of the problem. For this question, we need to find the time. Okay, so it's a formula we've seen before, but I've never had you solve for T, right? I've only had you solve for the balance. But now that we have learned some new skills, now we can solve for the time as well. Okay, so what do we do first? Well, remember, we always want to start by getting the exponential term by itself. So let's get rid of the 5,200. That's a coefficient. Okay, so the 5,200 is multiplying the E. So let's divide both sides by 5,200. Okay, so on the left side, if I were to type 6,000 divided by 5,200 into my calculator, it gives me a long decimal that goes off the edge of the screen. Okay, so you never want to round mid-problem, right? So I would not want to just call it 1.15 or 1.1538. Even if I write every single digit, that's still not exact. The numbers go on forever. Okay, so instead of doing the decimal, I can just keep it as a fraction, right? Or I can reduce it. Okay, so the mixed number would be 1 and 2/13, but the improper fraction would be 15/13. Okay, so let's reduce the left side to 15/13. Okay, so next, how do we get the variable out of the exponent? This was situation 4 on last lesson, but you do some sort of logarithm of both sides. For this particular problem, because the base is e, it would make the most sense to do natural log. Okay, so let's do the natural log of both sides. Okay, so you take both existing sides and make them the argument of the natural log. Okay, so continuing over here. The left side cannot simplify, just leave it how it is for now. But the right side, we know that natural log and e are inverses, they're opposites. So natural log of e cancels out. Okay, and that leaves just a 0.05t behind. Okay, so we've gotten the variable t out of the exponent, but it still has a 0.05t attached to it. So let's divide both sides by 0.05. Okay, so the 0.05 cannot go into the argument. It would only affect the coefficient if there was one, but there isn't. Okay, so this would be your exact answer if I asked you for that. I actually didn't specify what I wanted here. So let's go ahead and also approximate this. Okay, so once you get to your exact answer, you just need to type it into your calculator in order to get a decimal approximation. Okay, so we have the natural log of 15/13, and then close that argument up, and that is getting divided by 0.05. Okay, so we'll just round to the 100th again. Again, on like a test, I would tell you where I want you to round to. But after the 6, the next digit is less than 5, so we keep it at 6. So 2.86. And what are the units here? Time is in years. Okay. So questions on any part of this first example? Okay. So another situation that involves exponentials and logarithms is what's called half-life. Okay, so some of you have maybe taken like a chemistry class, maybe familiar with this concept. So basically, a lot of things in nature are like unstable. They break down over time. So there's something called a half-life to measure how long it takes for half of the substance to remain. Okay, so a formula that we can use is given here. Y equals a times 0.5 to the power of t over k. Y is the final amount of that element, A is the initial amount, T is the time, and K is the half-life, which again is different for each element. Okay, so again, on this whole page, there's going to be 2 questions per problem. Okay, so the first question, okay, if a substance has a half-life of 6 hours, how much of a 40-gram sample remains after 18 hours? Okay, so let's go ahead and use the given half-life formula. Okay, so what are the numbers they gave us? They told us the initial amount. We're starting with 40 grams, so A is 40. There have been 18 hours that passed, so the time is T is 18. K is the amount of time known as the half-life. So it tells you right here, half-life of 6 hours. So K is 6. Okay, and then the question is how much remains? How much is left over at the end? So what's the final amount? So Y is the unknown. Okay, so again, we see that the variable Y is already by itself. So we just need to type the right side into our calculator. Just a quick warning, those of you with TI calculators, you likely need to put parentheses around the exponent before you type it in. Okay, so the answer that you should get is 5. Okay, and then what are the units of this? The amounts are in grams. Okay, so that's the first question. Second question, how long until there are only 2 grams left? All right, so again, same formula, same situation. Okay, but what are they asking us this time? We want the final amount, which we're calling Y. We want the final amount to be 2. Okay, you're still starting with 40 grams. And it's the same substance, so the half-life is still going to be 6. But what we don't know is the time. We don't know T. Okay, so this time the variable T is not by itself. It's with a bunch of other stuff. Okay, so common mistake, you cannot multiply the 40 and the 0.5 to get 20. The 0.5 is first affected by the exponent. And remember, order of operations, exponent comes before multiplying. So you cannot multiply the 40 into the 0.5. Okay, so instead, to get the T by itself, let's get rid of that 40. Okay, so the 40 is currently multiplying the 0.5. So the opposite would be to divide both sides by 40. Okay, so on the previous problem, I said keep it as a fraction because the decimal goes on forever. This fraction does turn nicely into 0.05. Okay, so you can use decimal here, or you could still do fraction. Either one is fine. I'll do decimal this time. It's a little confusing because 0.05 looks like 0.5, but obviously they're different. So just make sure you don't mix up which one is which. Okay, so we have this equation at this point. To get the exponent, the variable out of the exponent, we're going to we're going to do a log of both sides. So on the first problem, I did natural log because the base was e. But here, the base of 0.5, you can do, log, you can do natural log, doesn't really matter. I'll just do regular log this time, I guess. Okay, so remember, the reason we do this is because the power property states that if a logarithm's argument has an exponent, you're allowed to move it in front as a coefficient. Okay, so the left side will stay the same for now. But the right side, we're going to move that exponent of t over 6 out front as a coefficient. Okay, so the variable t is still not by itself. I'll go ahead and multiply both sides by 6. Okay, and then lastly, the t is attached to the log 0.5, which means that it's multiplying it. So log 0.5 is just a number. You can divide it away. So divide both sides by log 0.5. Okay, and that gets the t by itself. Okay, so 6 log 0.05 over log 0.5. Okay, now this answer, while exact, is not that useful to us, right? I don't know how much this is. So let's go ahead and turn it to a decimal. Okay, so again, using our calculators, let's type this in and let's do a decimal to the nearest hundredth. So keep 2 decimal places. Okay, so your answer should round to 25.93. And the units, this is a time. So the units of time in this problem are hours. Okay, so questions here? All right, so besides interest in a bank account, another situation that involves exponential growth is population, right? The more people there are, the more children are born. So every year, in most situations, the population goes up by more than the year before. Okay, so population in 1990 was 400,000. What's the predicted current population here in the year 2024? Again, there's 2 different questions here, so let's answer this one first. Okay, so what formula? They didn't give us a formula. Well, it's exponential growth. Okay, so we're just going to use the compound interest formula, but with n equals 1. Okay, so we're going to use a equals p times 1 plus r to the power of t. Okay, so where does this formula come from? The compound interest formula looks like this, but I'm telling you that n is 1. So if n is 1, r divided by 1 is just r, and 1 times t is just t. Okay, so the initial value, 400,000. Normally it's the interest rate, but it's the rate of growth. R is 5%, which is 0.05. Okay, and then T, the time, that's the number of years that have passed. Okay, so the year is 2024, but that's not T. T is the number of years since 1990. Okay, so 34 years have passed. So that's T. All right, so variable is by itself. Let's go ahead and type this into our calculators. Okay, so when we were dealing with money, we rounded to the nearest cent, the second decimal place. But for this problem, we're dealing with population, with people, right? So we're going to round to the nearest whole number. Okay, so that was the answer to the first question. The second question is, in what year do we think the population reached 1 million? Okay, so we want to know when the total amount, the final, equaled 1 million. So that's the goal. Okay, you're still starting with 400,000. The rate of growth, R, is still going to be 5% or 0.05. Okay, but this time we don't know T. We don't know the time. That's what we're trying to find. Okay, so we need to figure out how to get the variable by itself. Okay, so why don't we have everyone try this without me doing it first? Okay, look at the examples above and see if you can come up with T and use that to answer the actual question. Okay, so you can start a couple of different ways. You can actually start by combining this up if you want, right? Because those are just numbers, there's no variable. You can also divide both sides by 400,000. Okay, so the left side becomes 2.5. And on the right side, I'm going to go ahead and add this up. 1 plus 0.05 is 1.05. From here, we need to get the t out of the exponent. So you can do regular log, you can do natural log, you can do other bases. I'll do natural log this time. Again, there's no real advantage one way or the other this time. I just chose natural log. Okay, so now that the right side is natural log of 1.05 to the power of t, we're allowed to move the t in front as a coefficient. Okay, so these parentheses aren't necessary anymore. Okay, and then the t is multiplying the natural log of 1.05. So the way you get rid of the times ln 1.05 is you divide both sides by the natural log of 1.05. Okay, so we get, I'll just jump over here, t is equal to the natural log of 2.5 over the natural log of 1.5. Okay, so I'm sure some of you got this instead, right? You did log of both sides instead of natural log. Let's see if it makes a difference. Okay, so natural log 2.5 divided by natural log 1.05. Sorry. Okay, so 18.78. What if instead of natural log, I did regular log? Exact same number. Okay, so it doesn't matter which type of log you use. Okay, so this was not the answer though, right? The question was not how many years have passed. The question was in what year? So remember, the problem started in 1990. So 18.78 years have passed since then. Okay, so 2008.78. This is a little bit of a, so you do not round this. It's still the year 2008 until it completely rolls over to 2009, right? If you think about us currently, we're in December of 2024. So the year would be like 2024.9, but it's not 2025 yet, right? It's still 2024 until it's not. Okay, so that's not the main point of the problem, but the actual answer would be in the year 2008. All right. Okay, so the rest is more practice. Okay, thank you. So I'm going to ask you to continue from here. For problem 4 and 5, you'll use the same formulas we used earlier today, so you can use those again. Problem 6, you need to figure out the formula yourself. So my recommendation for problem 6 would be to make a table of values. Do the first few values by hand, and then maybe you can figure out the equation from there. Okay, so I'll give you a good amount of time to work. If you finish, on the back is some mixed practice of solving equations. Okay.